Okay, this is solving equations using fractions, part 2, another problem. We're instructing and modeling for students how to solve equations that involve fractions. This time I'm going to ask for Tamia to help me out just in case I get lost and tell me the problem. Add another page. We're going to do something a little bit differently this time because we know that when we take our PARCC assessment, we're not only going to have to solve problems computationally, meaning do the addition, the multiplication, the subtraction, etc. We're also going to have to explain our thinking. So when we solve this problem, we'll solve it together, but then I'll ask for you to go back and write down what you did to solve the problem. That's called the algorithm, correct? Yes, okay. So Tamia, I need help. What was the problem? F equals 6. Okay. Now we have to get some foundational knowledge established. Now, I see somebody on their Chromebook again. This is why we're not able to keep up. Right now, we're not on the Chromebook. Right now, we're writing down 1/2 times F equals 6.
What's that dot for?
No. We have to raise our hands, okay? And if you give me a second, that's exactly what I was going to explain. You have a quick question? Hold on, this is what I'm about to explain. Thank you for clarifying. So, remember I said we got some foundational knowledge that we have to establish? That's what I was going to explain. Well, let me say this. You can express multiplication a few different ways, okay? You can express that you're using the operation of multiplication a few different ways. You can do this. Wait, let me erase it because I would like for you to write down what I'm writing down. I'm writing down expressions of multiplication. And expression just means that I'm showing multiplication. I haven't written anything down, so hold the question just yet. So the first way that we could express multiplication is by saying 1/2 F, right? That means multiply. I want you to write this down whether you know it or not, okay? You have to record this. The second way we could express multiplication is we could say 1/2 times F. This dot is an indication of multiplication being the operation. We can also say that we're multiplying by writing the problem this way. 1/2 times F, right? This is a common symbol that we're using. And lastly, for here and now, we can express multiplication like this, with parentheses. Because anytime you see a number next to a set of parentheses, that tells you to multiply. Tyreek, do you have a quick question before we solve this problem? You can't see because I'm in your way. Okay, well then you'll just have to wait until I move out of the way because I'm always going to be in somebody's way. Alright, so we express multiplication by writing a number next to a variable through a single dot, through the standard multiplication symbol, and through parentheses. The goal, one more time, is for us to model the proper way to solve this kind of problem, and then I'm going to put the onus back on you, and you'll explain in words, clearly and briefly, the algorithm. You'll just say what you did to solve the problem. Step 1, I figured, for example, you'll say step 1, I figured out which number to eliminate. Step 2, I eliminated that number through inverse operation. Or step 2, I divided something on both sides, right? Okay, yes.
What is the difference between a parenthesis that has an equation but a parenthesis that only has a single number or
Good question. Good question, and I'll erase this. This is Caleb's question. What's the difference between this versus what's the difference between these two, right? The difference between these two is that this setup is just asking you to multiply. This is saying, it's going back to order of operations. And it's saying, do the operation in the parentheses first, and then when you get the answer, 13, then multiply it times a half, right? All right, so let me erase. Okay, which number do we have to eliminate to get the f by itself? We have to eliminate 1/2. And Tyreek, what's the operation in the problem? Multiplication. So what do I need to do, Charity, to get rid of the 1/2? So I think what I hear you saying is that you need to divide 1/2 on both sides of the equation. Yeah. So let's do that. And actually, I'm gonna write it over here to indicate that this is the second number. I'm gonna do divided by 1/2, and then 6. I'm going to divide by 1/2, right? Any questions about why I wrote divided by 1/2 on both sides?
No.
Because that's the number I'm getting rid of. Multiplication is the operation in the problem, so I'm dividing or doing the opposite. Okay, is what's on the screen here too. Jaylon, it looks like you just need to add the divided by 1/2. Okay, so if we just concentrate on the left side of the screen, we'll see that this multiplication and division has canceled out the half.
Since you divided by 1/2, why do you have to cross out the 1/2 on the right side?
Well, I'm not crossing anything out on the right side. I would only, because that's showing that they canceled out. The crossing out is just indicating that those numbers are no longer there. I don't want to make them disappear from the problem because they have to be in here to indicate what I did to get half to go away. Yes, yes. It's not the numbers that are canceling out, it's the operation. It's the, see, these two are inverses, they're opposite, so they're canceling each other out, which makes it possible to cancel this number out. Right? All right, so on the left side, and we always have people that don't cooperate within a class, over here, these two have canceled out, so I'm left with F, and I've done a good job of isolating it, getting it by itself. But now on the right side, I still have 6 divided by half that I need to deal with, right? Okay, and so this becomes a familiar problem because I'm dividing, and so because I'm dividing a fraction, I'm actually going to multiply by the, what's it called? By the reciprocal. Good job. Alright, so I'm going to rewrite my problem as such. F is equal to 6 over 1 times 2 over 1. Now, does anybody have any idea where this 1 came from? Zachary?
You have to add a 1 because that's the
Yes, I had to give 6 a denominator. Do I always make, when I want to change a whole number into fraction form, do I always use 1 as the denominator?
Yes.
Absolutely, I absolutely do, because that, it leaves this number the same, it doesn't change the value at all. 6 and 6 over 1 are equal.
So if you like saying 6 divided by 1.
Yes. Well, let's look at that. How many times is 1 going to 6? 6. fraction format. Dividing fractions always means that you multiply by the reciprocal, so that's what I did. And this is a very easy one, right? Because now that I have this problem written as a multiplication problem, I'm just multiplying straight across. And I'll just set that up for you. It's 6 times 2 over 1 times 1. So 6 times 2 would give me 12. And then 1 times 1 is clearly 1. However, as I just modeled for you up in the line above, when you have a numerator with a denominator of 1 in any fraction, it's always best to write your answer like this. Because 12 over 1 is equal to 12.
So why do you, since it's a division, why do you have to multiply it by this?
Why? Because that's the algorithm for solving the problem. What we can do is we can explain the theory behind it in tomorrow's lesson, so we won't take so much time. Yes, but with math, there's always a very specific algorithm. As long as you follow the pre-established steps, you'll always get to the right answer. That's why I always have us write out algorithms. Okay. I'm going to give us our math problem of the day now. So I'm going to insert a blank page. I'm going to write the math problem of the day on the board. I'm going to ask you to solve this problem independently. I'll give you about 2 minutes to solve, and then I'll come around and see how you did. Those of us that solve the problem correctly, you can go on and continue fixing the problems in your practice buddy assignment or completing the problems on the fractions worksheets. Those of us that don't get the problem right, I'll meet with you at the back table. Quick question. Thank you, I forgot all about that. I'm getting ahead of myself. No, okay, well, I'll do this. I'll help you out. And we all want to make sure that we're exuding an enthusiasm for learning and not talking unnecessarily in a negative way. I'm going to help you out. Thank you, though, Zach, for reminding me. We're going to solve the math problem of the day, and instead of explaining the steps for this problem, we'll explain the steps in the math problem of the day. Did you catch that? We'll do the math problem of the day. Hang on 1 second. And instead of writing out our steps that we use to solve this problem, we'll just explain the steps that we use to solve the math POD. Yes? You have to speak up a little bit because I can't hear over all the tapping. Say it one more time. What I'm saying to you is that some of us did last night's math practice buddy, and we had some difficulty. So if you did the practice buddy and you didn't, Crystal, grab my phone, say room 105 phone, please, but get it quickly before they hang up. I think if you can go back and change the problem and do it correctly and put in the correct answer, that's what I want you to do. If you have done the practice buddy and you left out problems because you didn't know how to do them, I want you to fix them. That's what I'm saying. Okay, as we solve our math problem of the day, we're doing it quietly and independently because I want to see who knows how to do this on their own. Step 1 is to solve the problem. Step 2 is to quickly write what you did to solve the problem. Is that a cue? Yes.